It's like, because it's not just science.
I will not answer that question right now.
So without Rusi Taleyarkhan's input to the experiment, our team had to follow his recipe for fusion from the published papers. In early October 2004, Seth Putterman and his team went to work.
In addition to how carefully it's degassed. That's actually the biggest key that
First, they set up the experiment.
we have to get rid of the dirt, or else it's just going to cavitate everywhere. So we have to make sure we filter it to get rid of it.
They started with a liquid in which the bubble would be created, a liquid called acetone, to which deuterium, the type of hydrogen needed for fusion, was added.
And so we have to make sure we filter it extra well.
It was treated to remove any excess gas that might prevent the bubbles getting hot.
Now what comes across here? I don't understand. That this comes to here and then out somewhere?
And that goes down to the trap there. And that's what
Then came the neutron generator, the vital piece of equipment needed to make the bubbles. Rusi Taleyarkhan used 2 different types of neutron generator and got fusion both times. So our team made sure their generator matched one of those. Then the flask in which the bubbles would be created was installed.
The cell looks a little bit foggy. It's still cold from the refrigerator.
Rusi Taleyarkhan said that the design of the flask was important. It had to survive being bombarded with sound waves. So our team ensured that their flask was up to the same job. Finally, Seth Putterman made one major improvement, and a neutron detection system much more accurate than that used by Rusi Taleyarkhan was installed. Using this, Seth Putterman would be able to record any fusion neutrons at the exact moment, the very same nanosecond as the flash of light. If there were any there at all.
So just to be clear, that we can really compare the 2 experiments.
Because of the specialised nature of the equipment, not everything could be identical. So we asked our UK experts to scrutinise whether minor differences in equipment were likely to prevent fusion.
There is one classic difference, which is the source of the neutron.
The energies are different. The source produces lower energy neutrons.
Now, would that matter?
Not according to Taleyarkhan, because in his first paper he said he got this effect.
The neutron generator got a clean bill of health.
Is the sound wave that he's applied just the same?
Slightly different frequency?
Yeah.
Minor. I don't think
Minor
that would.
You don't think that would matter?
No.
Okay, so...
And so, our experts were convinced that the recipe for fusion laid out in Rusi Taleyarkhan's published papers had been followed as closely as possible. Confident that he could reproduce Rusi Taleyarkhan's vital scientific conditions, Seth Putterman went to work.
So if we got the deuterated acetone in the cell?
everything degassed as well.
So we're cooling down now in order to get to 0 degrees?
Yeah, we're getting there. We're at 7.5 degrees.
And Brian put the source in.
Yeah.
Ready to roll. Let's get the data. Let's see what we can find.
Yeah.
On October the 7th, 2004, the test chamber was sealed. The sound waves started, and the experiment was underway. In 2 6-hour runs, spread over 3 days, sound waves bombarded bubbles inside the flask. And the neutron detector did its work, searching for neutrons in the same nanosecond as flashes of light. To give the experiment the best chance of success, data from 4,000 bubbles was painstakingly recorded.
Looks like a really good resonance. It's good.
really good.
And when the experiment finished, to ensure fair play, all the data was sent off to the UK to be thoroughly checked and analysed.
So let's try summarise the different results that we got from
A few weeks
Taleyarkhan
later,
and from Seth.
our team came together
The
to
very
discuss
first
the
thing
results.
We'd expect them both to see were the bubbles. Are the bubbles reasonably similar, or can we say there are a few differences?
They're the same,
They're the same,
as far as we can tell.
as far as we can tell, okay? And then we've got the sonoluminescence. So these are the flashes of light. We know that Rusi saw them. How about Seth? Did he get that too?
Yes, he saw it as well.
So there's a load of energy being produced. We know
It was clear that our experiment successfully produced bubbles that gave off flashes of light.
When you get the flash of light, that's exactly the same time that you expect the neutron to be produced.
Yes, if the neutron is coming from fusion, you'd expect to see it at the same time as the flash of light.
But then it came down to the biggest question of all. Just how many neutrons did Seth Putterman record in his neutron detectors in the exact same billionth of a second as flashes of light?
And how about Seth?
None above the background.
None.
None at all.
Our experiment failed to find any evidence of fusion. We put this conclusion to Rusi Taleyarkhan. He said that it had taken him several years to perfect the exact conditions necessary for fusion, and that because our experiment was not an identical copy of his, any one of several differences might have affected the outcome. Nevertheless, we followed his fusion recipe as closely as possible, on the principle that if the key scientific conditions are reproduced, the results should be too. But we found nothing. It is possible that other scientists may succeed in reproducing Rusi Taleyarkhan's results, but for now, all we can say is that the dream of a shortcut to unlimited, clean energy forever must remain just that. A dream.
Next week, one of the most controversial subjects in science, designer babies. Could we one day create a world where every child is genetically perfect? And if we could, would it be right? Horizon cuts through the hype to get at the truth. What is a designer baby, and can we really create one?